Hey there, and welcome back to Richmond Woodworks. I have my coffee ready to go, and what we're going to be focusing on this weekend is finally getting around to creating the cyclone dust collection. So I have my bucket, and I need to do some stuff to that, like take those handles off and such. And I bought a little while ago, you would have seen in one of the previous episodes, that I've had this ginormous dust deputy cyclone, and it comes standard with these 5-inch openings, which I don't really need, but it also comes with these little adapters, which you can pop on like that, and that takes it down to about 4-inch. Now, it's just a little bit bigger than an elbow for the 90mm pipes I plan to use. So I plan to 3D print a little adapter. So I'm going to run 90mm for the majority of the whole ducting system. And on that cam vac comes with this little adapter, but it nicely and neatly and quite tightly fits one of those 90-degree elbows. So that's just an FYI for anyone looking at using 90mm pipes or PVC pipes, the drainage pipes in your shop system. Rightio, so I have an idea of exactly what I'm going to do, and with a slight twist. So I've been watching Dennis from Hooked on Wood for a little while, so thank you very much for your content. It's very much appreciated, and I definitely appreciate, especially now that I'm doing this YouTube stuff, I definitely now appreciate the amount of energy and effort that you put into your videos. So he's gone ahead and created this little cyclone dust collection box with a little leverage kind of point to get this bucket nice and neatly up. And so it's not such a chore when you have to empty the dust collection or empty the remains of the dust collector. So I plan to have a little bit of a twist on that, just a little bit of a Richmond Woodworks flavor. So stick around for that, because I think it's pretty cool. Hopefully it works out, fingers crossed. But if it doesn't, it'll be on YouTube and you can watch me fluff around, try to work around some of the problems. Right, so this one's going to be pretty much a freestyle, because I'm going to be running off Dennis's plans, which I purchased, and I encourage everyone else to purchase and support content creators. But I'm going to make a slight twist to it, because his leverage mechanism, I'm going to be changing it around a little bit. So stick around and find out what I do with that. So let's get started in actually creating the box. So let's do it. So what I need to do now is try to seal the top of this. So when it kind of pushes up at the base of the cyclone, you want to have this fully sealed so it's somewhat airtight. It's not, going into space, but it needs to be somewhat airtight so it doesn't lose too much pressure in the whole cyclone system. And you can buy these things, and they're from Bunnings, and their insulation you usually put around copper piping. So, you find them in your attic or, the ceiling, where they're rubbing up against other things just to insulate it from your hot water system from burning other components like timber or whatever, if you have your studs in there. So what I'm probably going to do is just cut it to size and slice it down the center. Now, some of these ones you can buy where it's got adhesive inside already, and that would have been ideal, but I actually couldn't find it, which is super frustrating. What I'm going to do is just slice it down the side, put it on top, and then cut it towards the actual length required. And because it's genuinely just going to be pushed up against the top, it shouldn't need adhesive to stick to it, because it's going to have that friction and also that force pushed on it. So let's just get cutting and then put it on and see how it looks and see if it's okay. Now I also have a bit of just gaffer tape or cloth tape, and I'm going to just seal that so the two ends just meet nice and neatly, because as you can see they're split apart a little bit. And there you have it. Nice little, hopefully it works, sealed bucket to put underneath the cyclone dust collector. So now what we're doing, we've got the sealer on, or the bucket seal, trademark, on, and what we're doing now is just having a rough little guess around how wide we want it. So this is going to be the width. It's going to sit on the wall this way, and because it's going to be have a leverage point, we want it probably a little bit deeper than normal. Otherwise, if it doesn't have much leverage to have that angle kind of pop up and it doesn't move much, it might really get stuck, and then that seal might just degrade over time because just be getting pulled inside and out, and then it'll just wear out. So we might have it a little bit deeper than the width of the bucket. Ideally, it should be as narrow and compact as possible, but I think we just need a little bit more of that leverage. So I'm probably going to make it about 400 millimeters deep and 360 wide. The bucket itself is about 330. So I'm just going a little bit either side. And the intention is for the sides to butt up to the base of this thing. So the actual width is going to be the actual width itself. Right, so I reckon 400 just to have that lever, maybe 450. So shall I make it 445? Because that will make it the same depth as the cabinets themselves. So each one of those melamine upper cabinets is 445 millimeters deep. And if I also put, which I want to, a little door in front of it, just to match it up with some of those cabinets, so it just looks pretty uniform, I'll make it 445. And then I'll also give me enough leverage to push that bucket up and down with that linear actuator, which I plan to put in. Cool. So now we have exactly what the measurements are going to look like. Let's start lining it up and cutting it up, and there we go. So now that we've got the pocket holes on the bottom and top, I deliberately put in pocket holes on the bottoms, so when I put these sides in, the pocket hole is actually going to be sitting, actually why is that? Oh, you all right, need to do the pocket holes again because I put them on the wrong ends. Oh. You idiot. All right, let's try that again. And that's why we make plans instead of freestyling it. So then we make far fewer mistakes, but I never learn. All right, let's get on with it. Oh. Cool, so take 2, because I didn't draw up plans, and when I don't, I always make mistakes. So lesson learnt for the 50th time. Anyway, this is the bottom. I have the top just behind me to the right, and these are the 2 sides. So the intention is going to be, they're gonna go up like this. I'm gonna glue and screw them in with those pocket holes, as well as that top as well. And the reason why I went plywood this time instead of just melamine is that I suspect there's going to be a lot of weight if it's just like if it's full of sawdust, and even if it's fuller actually going to the dust cyclone itself because I forget to empty it, then I suspect it's going to carry a lot of weight. I don't know how much, but it'll be interesting to weigh that, a full bucket, a 30-litre bucket of sawdust, and see how much it actually weighs. I suspect it's going to be maybe 20, potentially 30 kilograms. So it's quite a lot of weight to just put on melamine. Usually they can take it, but just in case anyway. The gluing and screwing and all that stuff is going to be super, super burly. And my intention is to fill in some of these holes that I made for the pocket holes and paint the inside and paint the outside as well. So it'll look very, very similar to the melamine cabinets themselves. Right, so let's get on with gluing, screwing, and constructing essentially another box that we're going to put on the wall. So let's get to it. So a great little trick to get glue out of the corners is to use a plastic straw. And up until recently, McDonald's used to give out plastic straws when you got a drink, but now I think pretty much every place in Australia has gone paper. I haven't tried them. I'm sure they'd work okay as well, but they might just not last as long. So I keep a whole bunch of these things in the workshop just to kind of literally just go and then pick up a lot of that glue, squeeze it out, and then you can reuse this as many times as you like. And there you have it. Something a little bit different for Richmond Woodworks, making boxes and putting them on walls. So next thing we need to do is just cut out the back, and I'm going to pocket hole that in. So I've deliberately left it till now to exactly measure it up, because plywood tends not to be the exact measurements it says on the box. But that way I can just kind of free flow it. So what I'm going to do actually, so it's not really a mistake, I meant it all along, obviously, is use those pocket holes to screw into the wall so I don't have to make a full backing here. So save a little bit of plywood. I knew that all along. I just had you fooled. Anyway, let's get on with it. Cut out some more plywood and stick it in to the back here. And this thing's slowly coming together. So I've put in a couple of hinges just at the back there off camera, because it was really difficult to kind of get a really good angle to see what I was doing. And to be honest, my entire body was blocking the shot anyway. So what we now do is we have this little bucket. The idea is once we pop the bucket inside, and I still need to drill out the hole for the bottom of the cyclone. And once the new smaller linear actuators come, the idea is they're going to push this bucket up like so, and then have it with a little bit of force. And I think it was 12.5 kilonewtons for each linear actuator, and they're quite small. So I've bought 2 of them just in case one is not enough, but we'll see how we go with just the one. Worst case, I can save the other one for a future project. And it doesn't need a lot of force to kind of make that seal up the top. So the idea is going to be to push it up and hold it there essentially. I think that's pretty cool. So now I just need to cut out that hole on the top, and then I might pull everything apart, sand it, and then just paint it. So this is the top of the collection box, and what I need to do is find the center, and I've measured the Dust Deputy 4/5 inch, I think it's a Super Dust Deputy from memory, and that's a 132 millimeter opening, and there's a little bit of play to where the screws go in as well. So I need to find the center, measure out 66 millimeter radius, make a circle, and then we'll cut that out with a jigsaw. Cool, so made a little hole, kind of looks like a little toilet. Anyway, made a little hole. I need to sand everything back now. I just dry fit the Dust Deputy, and it fits perfectly around that hole, so I made that cut nice and easy. So just need to get rid of some of this dust that's floating around, sand everything back, and have it all prepped for some paint. So off camera, what I did was just apply another coat of white paint, and I filled in some of those little pocket holes that I mistakenly put in on the wrong edge and the wrong side, so stupid me. And also put everything back together just to see how it would work and how the bucket would fit in. And also what you'll find is after, I don't know, 4 or 5 hours last night of trial and error of where to put this linear actuator, because it's so huge, I finally settled on this location, and I'll go and do a deep dive as to why in a second and where else I tried to put it. Now, I originally had planned to put some of these little micro linear actuators, and they're 6.4 newtons at, I think it's 12 volts. Yeah, 12 volts, and they travel 30 millimeters. And to be honest, once the bucket's in there, this little lever only needs to go up 20, maybe 30 millimeters. So my thinking was, oh, that's perfect. You won't really see them. They're the exact height of this drop anyway. But the reality is that out of the 4 that I bought, 3 of them were duds, and they just don't move, and I have to literally pull them out a little bit for them to move. And when they do move, I literally just put my finger on top of it and it stops again. So I contacted the eBay store, and they said they'd gladly take them back. Only issue is I've trimmed the ends a little bit because I did have some of these little plastic connectors on the ends. Hopefully I still take it back, we'll see. But to be honest, I spent $100 on these 4 little linear actuators, and I'll be quite annoyed if they don't take them back. Anyway, that's just eBay, I suppose. So I bought this other linear actuator a long time ago in preparation for this build, but it's so huge and so beefy, it could almost tear this thing apart. It's got that much force. So I have to be really careful of how far I make it travel. Right, let me deep dive into exactly what I'm thinking of how the movement's going to be, and some of my thinking that I probably spent about 3 or 4 hours just last night experimenting with, and I'll show you my train of thought. So you can see a couple of hinges back there as the pivot point for where the bucket sits. So I've taken out the bucket, as you can see, and the idea is this is going to lift up, and it only needs to go up about 30 millimeters or so not too much in order to make that seal up the top. And if we kind of push this up all the way, you can see that linear actuator here. And what I've done is I've bolted it in at the back there. And the idea is going to be is that when this comes out, I'm going to have a little ramp on which this itself is going to move and then push up against this hard timber in order to move that entire platform up, and then squish that seal in order to make that completely sealed. Right, so what I have here is my variable voltage output, and I have it set to 24 volts at 5 amps. And this thing's directly connected through to, via positive and negative, through to this DC remote control. And this thing can take DC 9 volt to 30 volts. So I deliberately have it set to 24 volts because that seems to be a pretty common household power adapter you can buy straight off Amazon for about $10. You can buy 12 volts, you can buy 5 volts. They seem to be the normal kind of outputs for a lot of devices. If I set it to 30 volts, all that happens is this linear actuator just goes a little bit faster. At 24 volts, it seems to be okay, and it's not super fast, but at the same time, I don't have to spend, 30 or 40, maybe even $50 for a specific 30 volt power adapter just to make this thing go faster. And the reality is I'm not going to be changing probably the dust very often in this thing, maybe once every 2 or 3 weeks. And if I have to wait an extra 10 seconds, I'm happy to do that to save about $30 or $40. So this thing's connected through to this remote via positive and negative input, and the motor itself output, there's no positive and negative indicator here, because how linear actuators work is if you have a certain polarity, it'll push the rod out, and if you reverse that polarity, it'll pull the rod back in, and that's how they work. So I have this remote, it's hooked up to here, set it to 24 volts at 5 amps, and all it does is and you might be thinking, how exactly is this going to be pushing this thing up when it pushes out this way? Let me show you now. So you might be wondering how a linear actuator pushing out is going to push this board up, and that's something I lost so much time trying to think about over the last few weeks. And initially I thought maybe having a couple of brackets, one here like so, and then having this thing at a fixed point. So the idea being that when this thing goes out, this is fixed to this point here on the board, and this thing goes up. And I thought that was a pretty good idea. But the reality is I couldn't find any more of these types of steel brackets. So I 3D printed it, but it's a little bit too flimsy. And I thought maybe I'll put that as plan A. And then plan B was to mount this linear actuator on the side here and essentially push and pull the board up. Now there's two issues there. A, this thing's so chunky the bucket didn't fit anymore, so that didn't work. But also, as you pulled it up, it pulled on one side as opposed to the other, and I really didn't want to have two massive linear actuators sitting in this box and then the bucket itself couldn't fit in. So then I went to plan C and thought about mounting it at the back here and having a series of pulleys that will come down and pull this thing up. But again, what would happen is it's got so much force in it and clamps down so much that this thing would also rock up as well. So I had to go to back to plan A, and my thinking was either having those two brackets together to push this thing up, or some other mechanism to push this thing up as well. And if you have a look at Dennis's video from Hooked on Wood, he went a little bit opposite. He had a clamp which pushed in, which had a bunch of boards up here that pushed this thing and squeeze this thing up. My thinking is doing it on the reverse side. So what I did, I 3D printed a few wheels, and the idea is going to be to have these wheels attached either side, almost like a skateboard, and have a bit of a ramp on a 45-degree angle on which this thing pushes up and then pushes this thing up and out of the way. And the good thing about that is if I have the ramp here and then pointing down towards the linear actuator bottom here, it'll have a nice little visual barrier so you don't actually see inside there, including a lot of these pocket holes around the place. And if you do have to do any maintenance, all you have to do is take the bucket out, lift this little lid up, and then you can get back there to do any kind of maintenance or adjust some of the cabling. So let me assemble this little bracket. I had to go out to Bunnings just this morning to get a 150 millimeter bolt because all I had was 120 millimeters, and so it's going to be quite wide, but I wanted as much surface area as possible so it's not putting a strain on individual parts, and try to manage the load and spread the load across a wider area. So let me put that together now and show you what I mean. So the idea is going to be having a bit of a ramp here on which these wheels can go. So maybe about 45 degrees or so. And as you can see, as it pushes forward, the whole mechanism goes up. And then it's going to stop at a certain point, or I'll make it stop at a certain point once that bucket actually goes up and squishes to the roof. And then when I need to change the bucket, the force from the bucket and its weights will push down on this little mechanism to pull this bit of timber back down, and I'll be able to remove the bucket. So let me show you what I'm thinking, and then what I'm going to do is actually construct one of these little 45-degree angled components and see how that works. So I have a bit of scrap timber here, and you can see just off camera I have the other little bit on a roughly 45-degree angle. And if we put this thing inside, align it where it needs to go, and then hold these two components here, you'll see I've marked a line where it should be normally sitting will actually go up. There's a lot of force on that. It's actually almost squishing my fingers, but I can't see any light coming through on that. And so this thing's fully sealed and it's not really moving anywhere. So that's the idea. Now let's just kind of cut up some of these things on the 45 degree, make a little box on the 45, and we can screw it in so it doesn't move anywhere, and we'll test it out again. So it turns out that my table saw doesn't have the required depth to go through on a 45 degree angle. So I'm going to use the bandsaw probably for the first time this year. So It's crazy. Actually, I probably haven't used the bandsaw for probably a year. So every now and then it comes in handy, but in the meantime, it takes a lot of floor space on the workshop. So what I've done is just pivoted the table on a 45-degree angle. That's the maximum this thing can go. And I'll put the fence on the other side of the blade. So gravity just holds this bit of timber in. And I'm just gonna slice it through, and there we go. So let's connect this thing up to the dust collector and hopefully not stuff it up, because I don't really want to glue another couple of bits of timber together. So I don't tend to use the bandsaw very often, but when I do, it's one of my favorite tools. It's just easy to use. It's not super dangerous like a table saw where you really have to be alert. It's just a nice tool to use, and I don't use it often enough, and I should use it more. So I'm going to try and find some projects to use the table saw for. So I've got my little piece of timber. So all I did was just get two 2x4s and just glue them together and just present it nice and neatly. It's just got the type bond 2, so it sets a little bit quicker, and you can see a few gaps here and there, but I'm going to hide those. So let's see if this thing fits. Oh, very nice and tight. And I'm going to set it back about 16 millimeters, because what I plan to do is put in this little bit of MDF at the front, just so I can paint it. And when I do, MDF tends to come up a little bit better when you paint it, as opposed to just straight pine. Now, let's test this thing out. Let's put this lid down, and obviously the cord's going to go a little bit behind. I'm going to have a little cubby for it. So let's test it out. Pretty cool. Man, that thing's got a lot of force. Let's try it with the bucket and see how we go. Whoa. All right, that's well and truly sealed. And this is going to take a lot of force. And hopefully it doesn't rip the cabinet apart if I push the button for a little bit too long. Cool, so now all I need to do is glue this bit of MDF to the timber, take this thing apart, and just finish painting it, and we'll screw it in, I think, from the sides, from the side and from the bottom, and I'll also screw it in from the inside just to really make sure it stays put. This thing's very slowly coming together, and the amount of absolute faff that's been involved in trying to put this thing together, work everything out, work out the angles, it's been quite frustrating. So I'm pretty happy with it so far. I do need to put another coat of paint because there's little scratches here and there. I think I might put that same color as the upper cabinets just here, just to make it a little bit darker inside so you don't see some of those gaps, and those little gaps don't really come out too much, but we'll see how we go. So, glue and paint. I'm pretty happy with this and how it's turning out. So off camera, what I did, I just waited for this thing to dry and I mounted it underneath. So I have 3 10 gauge 50 millimeter or 2-inch screws. So pretty beefy ones to stop that force from that linear actuator pushing this thing out. So I really genuinely need to be careful with how far and how high I throw this up. So I also put the cable, just drilled a whole little hole in the back there, just so it doesn't come out this front anymore. And when I mount it on the wall, I aim to run the power cable down the side of the wall, so you won't even actually see it. Right, let's give this thing a go and see how it looks, eh? Pretty cool. And nice seal there. I did see this thing slightly move out a little bit, so I might need to just back it off a bit, and it's still a pretty decent seal. So I just need to play around with it and see how far I can actually push it without this whole thing ripping apart. Probably a good idea that I actually made it out of plywood. As I was painting everything, I was getting a little bit frustrated, and I just wished at that point that I just made it out of melamine, so I didn't have to paint and then sand and then paint and sand. But I'm glad I did it out of plywood, especially this 18 millimeter plywood here. So starting to come together. Now all I need to do is make a little door, and the idea is going to be it's going to hide all this stuff behind it. So when I open it up, then I have full access to this whole bin. And I also need to mount the cyclone on top and mount it to the wall, and then start running some of the ducting and piping through to it. So almost done, the final stretch. So let's just crack on with it, hey? So in between coats, what I might actually do is start focusing on getting some of these electronics in and mounted inside. So all I have to do is just run that little cable once the power adapter comes later on this week. It should be here maybe tomorrow, maybe the day after, but I just want to leave it in a position. All I need to do is just literally just plug it in and I'm good to go. So let's start mounting a little bit of the electronics and do a little bit of cable management as well. Now, if you haven't seen these before, these are Wago clips and they are absolutely amazing. So what you do, you just put in a cable here, fold this thing down, put in a cable there, and what it has is a common bus across the back. So essentially you can use one for positive, one for negative, and what I'm going to do is mount these inside there. So if I have anything else I want to put inside there a little bit later on, which will require 24 volt, I can easily just add that to it. Super simple. Love these things. All right, note to self, make sure you turn off the power before you start playing around with electronics. Otherwise it gives you a little fright like it did then. I just touched the two cables and it just started zapping. Anyway, it's only 24 volts, so it's not the end of the world, but definitely food for thought. Now, you don't need to hot glue down every single cable, but it does satisfy your OCD, so you know you want to. Anyway, I'm going to put another coat on the door that's sitting just behind me over there, and then we'll need to wait for it to dry again. So this is going to be painstakingly slow. And there you have it, done and dusted, pun intended. Anyway, so what I did off camera was make a little positive stop, just so when I push that bucket in, I know exactly where it needs to go, and it's perfectly centered with that top hole there, which goes up into the cyclone. I still need to mount this thing on a wall, but I'm not going to do it just yet, just purely because I want to run some of the ducting, and I don't know exactly where it's going to spit out just yet. So I do have a bit of movement on the wall, as well as on this other wall here, where I can kind of have this thing mounted in terms of like vertical and also left and right. So I won't mount it just yet until I've done that ducting. So if you do want to have a look at that, click that little subscribe button below, and then you'll get notified when I do the ducting work, which is probably going to be in a week, maybe two, because I do plan to do a little video, like a short one this time, not something that's 45 hours long like this one, into exactly what I learned along the way. I went through countless amounts of parts, countless amounts of variations of things, and I plan to kind of deep dive into, hey, if you're thinking about doing this, don't do it this way. I tried, it didn't work for me, yada, yada, yada. So stay tuned for that one as well. In the meantime, I'm going to put this thing away. Positive stop, not bad. Play. Pretty cool, huh? I'm pretty happy with it. So like, subscribe, and please comment. I really enjoy interacting with each and every single one of you. If there's any suggestions for this thing, I'm absolutely all ears. So I'll see you all in the next one, and take care of yourselves. All right, bye. Try it with this thing. Ow! Oh. Ouch.